All right, Madison, the question that you ask about in terms of the roots, the real roots and the imaginary roots, if we have the function f of x is equal to x seventh minus 6x to the 6th plus 12x to the 5th, that big long function, and you graphed it and you saw that it did cross at x is equal to 2. Now what I'm going to do on this is I'm not going to talk about whether it bounces or whether it crosses. We're just going to prove exactly what the multiplicity of that 2 is. So what I've done is I've used synthetic division, and with the synthetic division, this may be just a short review over doing that. I've listed all of my coefficients, and then I brought down the first one and divided. Remember that x equal 2 would mean that x minus 2 is a factor, and what we would have to do then is to put in the box for the synthetic division the number after the minus sign. So I did the synthetic division. I found that it did go. My new equation would become x to the 6th minus 4x to the 5th plus 4x to the 4th plus x squared minus 4x plus 4. I graphed that new equation, and it shows that x is equal to 2. As a matter of fact, it bounces at 2. So that would mean, again, that x minus 2 is a factor. So I did synthetic division on that equation, and when I did that, I ended up with a new equation, x to the 5th minus 2x to the 4th plus x minus 2. I then typed that into Desmos. I saw that it was, again, 2 was the solution. So I know that x minus 2 is a factor. And I did synthetic division one more time. So I did synthetic division using 2, and I get the result x to the 4th plus 1 as my new function. I now graph that function. It does not cross the x-axis, therefore this means it has 4 imaginary roots. So the correct answer to the problem would have been that it had one real root with a multiplicity of 3 and 4 imaginary roots. Now, if we use the bounces and the crosses, okay, first of all, it crossed at 2, which means that there is a possibility, this means that you are going to have odd multiplicity. Okay? And there was one time that it bounced at 2, which meant that the multiplicity here was 2. So with the odd multiplicity, it doesn't just mean that it's 1. Okay, odd multiplicity, since you actually have 7 roots. It could be 1, or it could be 3, or it could be 5, or it could be 7, depending on what you had. So if you had, let's take an odd multiplicity of 1. That would mean that your multiplicity of 2 would be 3, which means that you would have 4 imaginary. Okay, and this is when we're doing the odd multiplicity of 1. You would have your 1 for crossing and your 2 for bouncing. All right, or it could have been 3, which would have meant you would have had 3 for your crossing and 2 for your bouncing, which would have given you a multiplicity of 5, which would mean only 2 imaginary roots. If your multiplicity of 2 where it crossed is at 5, Then we would have 5 for crossing, 2 for bouncing, which would be 7. So you would have 0 imaginary roots. Okay, and it can't be 7 because we know we have a multiplicity of 2, and 7 plus 2 would be 9, and that's more roots than we actually have. So the combination that would work would be that we would have the 4 imaginary roots, the 1 real root, and 4 imaginary. Okay, I personally, to be exact, I like to do the synthetic division. If you have a question on this, just let me know. Hopefully this will help you to see what takes place.